Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today completing the square. And this will involve equations in the later part. Let us see the problem set on the other screen. Okay, so over here. All right. This will be our problem set. Completing the square. This will be our lecture examples. And the instruction is find the value that completes the square and then rewrite as a perfect square. At the lower part of the problem set, we will have the equations. So we will be having there solve each equation by completing the square. So I'm going to discuss the details for each topic. All right, so let us begin with the first number using the presentation view. Okay, we shall begin from here. Okay, find the value that completes the square and then rewrite as a perfect square. So this is the instruction. So you can see here the quadratic expression, and we're going to identify the required number to complete the square. Now the basic formula for completing the square is to get the coefficient of the first degree variable and then divide by 2 and then square it. So if we're going to have something like this format, to get that particular number to be added so that it will be written as a perfect square, then you will have to use that number b, and then you're going to divide this number by 2. Afterwards, you're going to square it there. And this is the required amount, so that this can now be written x squared minus bx plus b over 2 squared. And then this is equivalent to x minus b over 2 squared there. So this is equivalent to this. Okay, we're going to use this in our given questions here, all right? Okay, so I hope you were able to see that part. All right, for number 1, we have r squared minus 34r. Our b here is the 34, okay? The 34. So what you're going to do is get that 34 is the coefficient of the first degree r, not the squared, okay? The coefficient of the r. So this is the first degree r. Now, after getting that number, you're going to divide it by 2. And then you're going to square it there. That will be the required number to be added. But then 34 is divisible by 2, and that is 17. And so we're going to square 17. So 17 squared means 17 times 17. Okay, and that is 289. Okay, how did we get 17 squared? 289. That's 17 times 17. All you need to do is multiply it by itself. So that's 49, carry a 4, you have 11. And then you have 1 times 7, 1 times 1. There. Then you proceed by addition. I'm just showing you how to square it. And how did I get that 289? So that's 9, 8, and 2. There. So the 289 is going to be added. There. Okay. Now the question is find the value and that's the value, 289. And then rewrite as a perfect square. Okay, rewrite as a perfect square. Now, to rewrite this as a perfect square, it will be a factor times itself, and that's equivalent to the square root of r squared, that is r. The square root of the 289 is the 17. There. And then we're going to follow the sign of the middle term. Okay, that means the sign that you see over there. So this will be a minus. Okay, and then we're going to enclose this and then squared there. Okay, rewrite it as a perfect square. All right, so let us see the answer. Okay, our answer is 289, of course. That's the number to be added. And then to rewrite it as a perfect square, that is r minus 17 squared. Okay, and that is equivalent to this trinomial. All right, let's find out. There. You can see the answer over here. There is the answer. Exactly what we did. Okay, so you see the 289 and you see the r minus 17, the entire quantity squared, it's over here. Okay, our answer here. All right, so I hope you were able to get that part. The more examples, the more we will learn. Let's have the second. All right, let's clear the screen. Let's go to the next number. All right, find the value that completes the square and then rewrite it as a perfect square. Okay, rewrite as a perfect square. Okay, we have here m squared plus 42m. Okay, like what I said, it's the number coefficient to the first degree. So we're going to use the 42. Okay, all right, so we're going to use the 42. And here is the given first two terms of the quadratic expression. Okay, you get that number, you get this number 42, and then you're going to divide this by 2. After dividing by 2, you're going to square it there. Okay, that's how to determine the number to be added to complete the square. Okay, all right, so this is 42 divided by 2, this is 21. Okay, 21 squared. Okay, 21 squared happens to be 441. There. Okay, how did I get 441 again? That's 21 times 21. There. So we have 1, 2, 2, 4. Okay, there. And then we proceed by addition. That's 441. There. And that's the required amount to be added here. Okay. And we're going to put it here. Plus 441. There. Now to express it as a perfect square, it will be square root of m squared, that's m. Square root of 441, it's the 21. There. Okay. Remember, to get the expression in the first, take it from here. Square root of that. And then to get the other term, get the square root of this. And then the sign of this happens to be a plus. So we will write plus there. And then this is now written squared. Okay, like that. Did you see that? I hope so. All right. I'll show you more details about this. And why is it that this is equal to this? I'll show you. Let me remove my multiplication here. M plus 21 squared means m plus 21 times m plus 21. Okay, this is equal to m plus 21 times m plus 21. There. Okay, that's the meaning of this. Okay, m plus 21 squared means m plus 21 times m plus 21. That's why it's called perfect square. All right. Okay, we're going to multiply term by term. Okay, m times m, that's m squared. M times 21, that's positive 21m. Okay, now we're in the 21. Okay, 21 times m, that's another 21m. And then finally, 21 times the 21. That's 21 times 21, it's over here. That's 441. So plus 441. Let's put a fence there. Okay. All right. Simplifying further, this will now be m squared plus 42m plus 441. And you can see exactly this is this one. There. Okay. And so these are equivalent. Okay. These two expressions here. These two expressions are equivalent. So I hope you were able to get the method. Okay. And where we started from the number, dividing it by 2, the result, you square it. That's the first requirement, the number to be added. Okay. After doing the addition, you will turn it into a perfect square. And this is what we did over here. Okay. Right there. Okay. So we'll go to the next. Let's clear the screen. Let's have the answer first. There. Okay. Exactly what we have a while ago. Okay. That's 441 for the number to be added here. Okay. And then we wrote the required perfect square. It's this one here. Okay. That part. Okay. All right. So that's it. That's the answer from the computer. And we will now proceed to the next. Let's have the third. Okay. Here's the third. All right. So we have here p squared minus 8p. What are we going to add there? All right, you will have to take the 8 there. Sprayer time. All right. Okay, I will do that later. All right, so 8, then you divide it by 2, and then the result, you're going to square it there. All right, so this is 8 over 2, this is 4, and then squaring it gives 4 times 4, that's 16. That's the required number. Okay, that means you're going to add here 16. Okay, that is the required number. That means you're supposed to add there 16. And what is this equal to? This is equal to like that. And then the first term here is the square root of this. Square root of p squared is p. And then the next term here, the other one, the square root of 16. That happens to be the 4. Okay, square root of 16 is 4. There. And then the sign here must be this. That sign, all right? It's a minus, then this is a minus. All right? Okay, so the required answer is the 16 and p minus 4 squared. Okay, all right. So let us see the answer there. Okay, the 16 is over here, there, and it is followed by p minus 4 squared. Okay, the required perfect square expression. All right, so let's proceed to number 4. Here's number 4. A squared minus 42a plus blank. All right, what is that number to be added? Okay, so it will have to be copied first, and then what is that number to be added? Okay, you're going to get that 42, the coefficient of the first degree of the variable. Okay, you divide this by 2. After dividing by 2, you are going to square it there. All right, so 42 divided by 2 is 21 squared. And we know that already. This is 441. Okay, so this is 441. And you can write this, okay, you can write this. The square root of a squared is a. Square root of 441 is the 21, okay? That's the square root. That's why we have 441, because we squared the 21, 21 times 21. So the square root of 441, it is written this way. The square root of 441 is 21 there, okay? So this is square root of 441, that's 21. And so the sign here will be the sign here. And then you put square there, okay? This is the required expression. This is the required number, all right? And let us see the answer there, okay? You can see the 441 here. You can see the required expression, a minus 21 squared over here, all right? So why is it a minus 21 squared equal to a squared minus 42a plus 441? You can always check that by multiplying a minus 21 by itself, okay? All right. So if you're going to check that, you can always check that. Let me clear this space over here. We can do a check always. Okay, a minus 21 squared, you can write it a minus 21 times a minus 21. That's the meaning of a minus 21 squared, okay? And so you can multiply this, and you can have a times a times the negative 21, which gives negative 21a. And then we are now here. 21 negative times a, that's another negative 21a. And then finally, negative 21 times negative 21. Negative times negative is a positive 441. After simplifying, you're going to have a squared minus 42a plus 441. And it returns to the beginning. It's over here, okay? There. You can see it clearly over there. A squared minus 42a plus 441. So we only need to learn here the required number to complete the square, okay? All right, so we're going to continue with number 5. All right, let's consider the next. Number 5, all right, here's the next. P squared plus 17p plus blank. Okay, I'm going to show you that the number beside the first degree letter, okay, the first degree letter, okay, that's degree 1, this is degree 2. The coefficient of the first degree is not always divisible by 2, just like in this particular problem. We have p squared plus 17p. All right, you will now use the 17, and then you will divide by 2. The result, you're going to square it, okay? And the result of this is 289 over 4. Remember, if you square a fraction, you square the numerator, and you square the denominator. When you square 17, that's 289. That's for the numerator only. Now, you're going to the denominator, which is 2, you will square that. So 2 squared is 2 times 2, that's the 4. So this is the required number to be added. So you're going to add here a fraction equivalent to 289 over 4. And then the next part is, so that's the first answer, okay? The second required answer is the perfect square, okay? All right, how do we make it perfect square? Again, the square root of the first term. The square root of p squared is p, okay? What do we mean by square root of p squared? Square root of p squared, there. And that's p, like that. Because this symbol, okay, this symbol cancels out with the 2, okay? It cancels out. So the result will be p to the 1, okay? All right, I'll show you that. All right. That square root of p squared, this means p squared, the radical symbol like that means 1/2, okay? And so 2 times the 2 times the 1/2 means 1, there. Because this will become 2 times the 1/2, there, okay? From basic algebra, all right? Okay, so let me clear that so we can continue. All right, so to get the required perfect square, the square root of p squared is p. The square root of the 289 over 4 is the 17 over 2, okay? The number there, okay? That's 17 over 2. Just before you square it, that's the square root. So we will write here 17 over 2. And then the sign at the middle will be the sign here, the sign of the original number coefficient of the first degree. So that will be plus. And then close parentheses, you have to write it squared there, okay? All right, so the answer here, the required answer here is this number and this, okay? All right, so we're going to verify that over there. And here are the answers. 289 over 4, semicolon, okay? That means the other answer is over here, there, which is p plus 17 over 2 squared. Exactly what we have in our solution, all right? Okay, I hope you were able to get that part. Whether the number beside the first degree is divisible by 2 or not divisible by 2, we will be able to solve that, okay? All right, if it's not divisible by 2, we will end up with a fraction like this, okay? We will have a fraction, all right. Okay, let's continue. Clear the screen. Proceed to number 6. All right, find the value that completes the square, then rewrite as a perfect square. All right, so again, we will have to start with the number beside the first degree. Okay, the first degree is the a. The second degree is the a squared. Okay, all right, the first degree has 11. Again, 11 is not divisible by 2, but still we will divide by 2. And then the result, we are going to square it there. And so that 11 over 2 is important. That will be written in the perfect square, okay? So don't forget the square root. That's the square root. The squared is 121 over 4. This is the squared, okay? When you square the 11 over 2, it will be 121 over 4. And that's the number to be added, okay? It's that number to be added here. There, okay? So we're going to add this 121 over 4. There. Okay. Now, how about that perfect square? Okay, the perfect square, all right, like that. And then we will take the first term here from the square root of this. The square root of a squared is a. The square root of 121 over 4 is the number inside here. That's 11 over 2. There. And then the sign at the middle now is the sign here. So that is plus. So the required answer is a plus 11 over 2 squared. Okay, so these are the answers, this and this. And we'll be able to check that over here. All right. So the answers are displayed by the computer. It's here. This is our number added. This is the perfect square. There. Exactly what we have over here. Okay, a plus 11 over 2 squared. All right, so let's continue with number 7. Let's continue with number 7. Okay, next, here's number 7. X squared plus 13x. What is the number to be added? X squared plus 13x. What is the number to be added? We will take the 13 and then we will divide by 2 and then we will square it. So 13 times 13, that's 169. That takes care of the numerator. We're now at the denominator. 2 squared is just 4. This is the answer. We will add this right here. 169 over 4. That means this is 169 over 4. Yeah. Now, how about the perfect square? All right, this will now be like that. Square root of x squared, x. Square root of 169 over 4. Take note of the number before you have the 169 over 4. That's 13 over 2. There. That's the square root of this. The square root, okay? And the sign of the middle, the sign of the 13 in the original problem. There. Okay? So this is the answer. And this is the answer. All right? So we have 2 required answers. And we shall see it over here. Okay? All right? 169 over 4 and x plus 13 over 2 squared. It's over here. You can see it right here. There. Those are the answers. All right? Separated by the semicolon. All right? There. All right, let's continue with number 8. Let me clear the screen. I hope you're getting the way to do it. Let's have number 8. All right, here's the next. Find the value that completes the square and then rewrite as a perfect square. Rewrite as a perfect square. So you have y squared minus 13y plus blank. All right, 13 is not divisible by 2, but still we can get the answer. 13 divided by 2 and then square. Okay, 13 times 13, because this is equal to 13 over 2 squared means 13 over 2 times 13 over 2. And this is equal to 13 times 13, that's 169. And then we have 2 times 2, that's 4. Okay, that's the meaning of 13 over 2 squared. Like that, okay? All right. Sometimes I'm doing a shortcut, that is why. All right, so that's 13 times 13, the numbers of the numerator to be multiplied, and then afterwards, the numbers at the denominator will be multiplied. That's how to do a fraction multiplication. So the required answer is 169 over 4. All right, it is now a perfect square trinomial, okay? That means we can express this as the square of a binomial. Yeah. Okay, the first term here is the square root of y squared. That is y to the first. And the second term is the square root of 169 over 4. That's 13 over 2. There. Okay. Guess what? What is the sign at the middle? Of course, it's obvious. It's there. That's a minus. So this must be a minus there. All right. Okay, that's it. We have the required perfect square. All right, and then this number over here. So we have this and this. All right, let's verify. Okay, that's 169 over 4 and y minus 13 over 2 squared. I hope you're getting the method, okay? Once you have checked on the step-by-step procedure, you'll be able to do it on your own. All right, so that goes to our number 8. Let's go to the next, number 9. Let me just clear the screen. Here is number 9. Oh, we reached the equation part, okay? Equation part. Solving equation by completing the square. So what we learned from 1 to 8 numbers or questions will be used now here, okay, to find the answers for the variable, the required value for the letters, okay? Remember, those letters in algebra represent numbers. All right, so solve each equation by completing the square. What is the value of r? We expect two answers here because this is r squared, okay? That means there are two values for r. All right, so let's start. Okay, we copy the problem. Let me write smaller because it might not fit. 18r minus 57 equals 6. All right, that's the given. Okay, the way to do this, and make use of the first two terms, the r squared and the r to the 1, okay? We are going to start there. All right, we're going to begin here. R squared plus 18r. Okay, we're going to get that 18, all right? Just like what we did a while ago, 18 divided by 2, after which the result after dividing by 2, you're going to square it. 18 divided by 2 is 9. 9 squared is 9 times 9. That's 81. Okay, so our number is 81. Now, we're going to use this 81 into the equation. Okay, if you're going to use this in the equation, you will have to insert it in the equation. Make sure you're inserting it in the right way. Okay, you will add it there. Make sure you're adding nothing. Okay, all right. If you add 81, you subtract 81. That means we added 0. Okay, so we did not change the problem. All right. Okay, after doing that, it follows we continue with a negative 57. Okay, you have that minus 57 there. Remember, you just placed it there. You inserted it in the equation, and that negative 57 is still there. And also the rest of the equation like that. Okay, this is legal here. Plus 81 minus 81. Okay, all right. You did not violate any mathematics rule there. You added 81 and you subtracted 81. All right, okay. After which, next step, we already know this r squared plus 81 and the 18r, the trinomial, r squared plus 18r plus 81. We can now replace that with the perfect square expression. We can now change this to r and 9, okay? All right. And then you copy this sign here, all right? That's plus. And then squared, okay? The things we did in the numbers 1 to 8, all right? This r came from r squared. The square root of r squared, that's the r. Now, this number 9 is the square root of the 81. Remember, it came from 9. That's why we have 81. We squared that 9. So in the perfect square, we're going to make use of that number 9. Okay, and so that is r plus 9 squared. That's the equivalent of the portion here. There. Okay, what happens to the negative 81 and the negative 57? That will be added. They are both negative. Okay, so we have 81 negative, okay, and negative 37, that is 138. There, 138, negative. All right. So this is now to be continued, negative 138, and that equates to 6. There. Okay. All right. After which, we continue. Okay. We're going to isolate the term with the squared because that's where the r is included. So we can do that by adding 138 to both sides. Add 138, add 138. There. All right. We will now have the left side r plus 9 squared. Okay. The 138 negative and the 138 positive is now 0. The right side will just give us 144. There. That's 138 plus 6. Okay. All right. So at this point, we're now going to take the square root of both sides. Take the square root. So we have r plus 9 squared. This is 144. Okay. All right. Take the square root. There. And then there. If you take the square root of a number, it will be plus or minus. Okay. There. Because we will have there plus or minus the square root of 144, which is plus or minus 12. Okay. Plus or minus 12. That means if you square negative 12, that's a positive 144. If you square a positive 12, that is also a positive 144. So there are two values. Okay. There are two values. Okay. There. So the square of negative 12 is 144. The square of positive 12 is also positive 144. So we have two values. All right. Now, what happens to the square root of r plus 9 squared? This will now be reduced to r plus 9 only. There. And then we will continue by transposing the 9 to the other side by subtracting 9. Okay. So we will have here r plus 9, and here is plus or minus 12. Okay. So subtract 9 and subtract 9. There. All right. What happens next? The right side will just be r. All right, let's put it at the right side. Let me clear something. Or we will just continue at the left. Let us continue over here. Okay. All right. The left side is now just r. Okay. And that equates to plus or minus 12 minus 9. There. Okay. We're now going to have two values. Okay. R1 is the positive 12 minus 9. R2, that is going to be the negative 12 minus 9 there. So we will have two answers, just like what I said at the start of the solution. Okay, 12 minus 9, 12 minus 9 gives 3. And negative 12 minus 9, that will be added, and that will be negative 21. Okay, so this is negative 21. And so the answers are positive 3 and negative 21. That will be the answers. Okay, and we shall verify afterwards. There, it's over here below the given. You can see it over here. There, that's 3 and a negative 21. They're separated by the comma inside the braces. Okay, the symbol for set. Okay, so 3 positive and the negative 21. And these are our answers. Okay, these are our answers. Okay, all right. So I hope you were able to see the way to do it. okay, from the beginning. And what you learned from completing the square is actually used here. All right, so let's continue. Clear the screen. Have the next problem. Okay, here's number 10. Number 10, n squared minus 16n plus 44, okay, equals 5. All right, okay. We're going to concentrate in the first two terms, n squared minus 16n, okay. We're now going to use the 16. We're going to divide this by 2, and then we're going to square it, all right. The result after dividing by 2 will be squared. So we have 16 divided by 2, that's 8. And then 8 squared, that's 64. Okay, do not forget the 8 because we're going to use that afterwards. Okay, so you add 64 and you subtract 64. Okay, just like in the first number. All right, after which we continue with the original part of the equation, and that's the 44. That means the plus 44 follows, equals, and the 5 there. Okay, at this point we can now convert this. All right, you know what those three terms mean. All right, this means this is like that, okay, and a square. All right, and that particular exponent 2, and this is now n, and the 64 returns to 8. Okay, don't forget the 8. I said that's the 64 square root. All right, the square root of 64 is 8 there. And the sign there, you know how to do that sign. It must be the minus, okay? You will find it there in the given. Okay, so we're done with the trinomial. We will now take care of the remaining numbers, okay? So we have minus 64 plus 44 equals 5 there. All right, what is negative 64 and positive 44? That will now be 20, negative. Okay, and we still have this part, n minus 8 squared, and we still have the 5 there. Okay, all right. Okay, after which we add 20. We add 20. All right, the right side becomes 25. The left side, it will just be the term inside the parentheses there, like that. Then we will take the square root of both sides. Square root, take now the square root. All right, let us not waste space there. And then when you square root, or when you extract the square root of a number, make sure it has a plus and a minus, okay? A plus and a minus there, okay? Because there will be two answers. All right, the left side is reduced to just n minus 8. The right side is now plus or minus square root of 25. Happens to be exact, 5 there. Okay, we're almost done. We will now be getting the value of n by way of adding 8 to both sides. We add 8 and we add 8 here. All right, and next line is n equals 8 plus or minus 5. Okay, you can rewrite that 8 plus or minus 5. So we continue over here. N1, the first value is 8 plus 5. Let's put a fence over there. All right, n plus 5. That gives 13. That's the first answer. Okay, how about n2? The second value, we call it n2. We will now have the 8 minus 5. And this is 8 minus 5, that's 3. So this is 3, the second. So we have two answers. Like what I said, in quadratic equation, you expect two values. Okay. All right. And so the answers are 13 and 3. Okay. 13 and 3. All right. Okay. Number 11. Let's have number 11. Okay, here's number 11. X squared minus 20x plus 45 equals negative 6. Solve the equation. The method is written. Solve the equation by completing the square there, because there are other methods. Okay, so this is by completing the square. So let us solve it. X squared minus 20x plus 45 equals negative 6. Okay, so we will now concentrate on these two first. All right, we will complete the square. We'll take note of the 20. We will divide this 20 by 2. And then the result will be squared. So this results to 10. Okay, and this 10 be squared. And 10 squared is 100. So the required number to be inserted is 100. Make sure you add and subtract. So this will be x squared minus 20x. We add 100. We subtract 100. Okay. All right. In that way, we added 0. All right. Next, we continue with the plus 45. And then the equals, and then the negative 6. All right. The original given. All right. So we simplify. These three terms here has an equivalent. We learned from the numbers 1 to 8. Okay, so this is equivalent to, all right, the square root of x squared is x. The square root of 100, it came from the number we were doing a while ago. It's the number 10. There. The sign here is the sign of the 20 originally. So that's a minus there. All right. Followed by negative 100 plus 45 equals negative 6. All right, let's take care of the numbers. So this is 45 and negative 100. So that gives us negative 55. Okay, negative 55. All right, so this is x minus 10 squared negative 55. There. All right, this is equal to negative 6. Okay, to continue, we will isolate the term with the parentheses, okay? Because that actually has the x variable. So in doing that, we're going to add 55, okay, to both sides. So add 55 and add 55 at the right, like that. And then the left side is now just x minus 10 squared equals, all right, that will be about, how much is that? That looks like 49, okay? 49, yes, positive. Because it's a positive 55 and a negative 6. So that will be about 49. Okay. At this point, you will have to take the square root of both sides. So you have x minus 10 squared, and this is 49. Take the square root, all right? And this is plus or minus square root of 49. That gives us 7, okay? And this is plus or minus 7. Plus or minus 7, all right? And the left side is just x minus 10. The square root symbol and the squared cancel each other, giving the binomial x minus 10. All right, we're almost done. So this will continue like we add 10 to both sides. This will now just become 10 plus or minus 17. There, okay? So the first value of x will be 10 plus 17. That will be 27. And then the other value, we will call it x2. That will be 10 minus 17. And that results to a negative 7 there. Okay. Okay. So that will be it. The 10 and the 7. It's only 7, right? 7. Yes, it's only 7. Let me erase that extra number 1 there. Let me do the correction. So this will just be 17. This will just be 17 there. And make that 3. Okay, this will be 3. Because that will be 10 minus 7. So that will just be 3. There. Okay. So that's 10 plus 7, 17, and 10 minus 7, that's 3. All right, that will be the first and the second answers. There. All right. I added extra 1 there. That's supposed to be not 17. It's only 7. All right. The answer is 17. Okay. Okay. So that will be 10 plus 7, 17, and 10 minus 7, which is 3. Let us verify the answers. All right. We have 17 and 3. Okay. Exactly what we obtained. All right, so let's continue with the next. All right, we have the correct answers. Let's continue with number 12. All right, let's have the 12. Here's the 12. R squared minus 2r equals 9. It looks simple, but let's see if it's really simple. Okay, solve by completing the square. Okay, let us put a space there right away, because we're going to insert some numbers. So r squared minus 2r equals 9. Okay, we will take the number beside the first degree. That's the number 2. Okay, and then we will divide this number by 2, and then the result squared. So this looks like 1 and then squared, and 1 squared is just 1 there. So our number is 1. That means we're going to add 1 and subtract 1 there. All right, and this trinomial here will be simplified to something like this. All right, square root of r squared, square root of 1 will still be 1. The sign will be minus, okay, taken from here, okay, as usual. And then this will now be continuing minus 1 equals 9. All right. Next step is to add 1 to both sides. So we'll be able to isolate the term with the r. So add 1 here, add 1 here. This will now be r minus 1 squared. Okay. And this will continue with the equals. The negative 1 and plus 1 gives 0. The right side is 9 plus 1, which is 10. There. So at this point, we're going to take the square root of both sides. So we rewrite it once more. And here's the 10. All right. We get the square root. And this is plus or minus. Okay. And so the left side will just be r minus 1. And this is plus or minus square root of 10. There. Okay. So at this point, we shall add 1. Okay. We shall add 1 to both sides. So this will become r minus 1. We have plus or minus square root of 10. We're going to add 1 here to cancel the negative 1, and we're going to add 1 over there. So r is equal to plus or minus square root of 10 plus 1 there. So we have first value, okay? We have the first value r1, and this will be 1 plus square root of 10. And then r2, we have 1 minus square root of 10 there. So these are the two answers, and let us verify. Okay, there. So we have it over here. We can see it over here. Check the answers at the left side of the screen. There, separated by a comma. So 1 plus square root of 10 and 1 minus square root of 10. Exactly what we have over here. All right, so next, let's have number 13. Let's continue with the next number. 13 is here. All right, solve each equation by completing the square. So we start with the given 9r squared plus 18r minus 31 equals -4. All right. Now take note of the first two terms. Okay, you don't have r squared. Okay, you have 9r squared. So we will have to make that r squared only. We are going to factor out the 9, okay, together with the 18. Okay, they are factorable. They have a common number 9. So we start here, put out the 9, and this will become r squared, and this will become plus 2r there. Okay, all right, you can always verify that 9 times r squared returns to 9r squared. 9 times 2r returns to 18r. So at least our factoring is correct. All right, now we're going to put a space here because we're going to add and subtract something. Okay, because we're now ready to take on the perfect square, completing the square procedure. Now that we have r squared plus 2r. Okay, so we're now going to concentrate on the 2. Okay, so we'll start with the 2, and then we divide by 2, and then the result we square. Okay, and that will be 1, then we square, that's 1. Okay, that means this is our number to be added and subtracted. So we're going to add here, add 1 and subtract 1 there. Okay, after which the equation continues to the minus 31. Minus 31 equals, as is, all right, minus 4 on the other side. We put a fence over there like that. Okay, let's continue now. We're going to have this trinomial inside. We know how to simplify that. That will be r plus 1 squared, okay? And that will be r plus 1 squared, okay? And that is still inside the first parenthesis, okay? Like that. And this is now with a minus sign there. And the number 9 there, like that, okay? And so we still have that minus 1 over there. We continue with the negative 31 minus 31 is equal to minus 4 there. All right, now we will distribute back the 9, okay? We're going to distribute back. This will be multiplied by the r plus 1 squared and also be multiplied by the negative 1. And so the next line will be 9 times r plus 1 squared. The 9 and the negative 1 gives a negative 9 there. And then followed by the minus 31 equals negative 4 there. I hope you were able to see that. Okay. After which, we will now going to combine the numbers. The negative 9 and the negative 41 turns negative 40. Okay. So the next line will be 9 times r plus 1 squared, negative 40 equals negative 4. And then we will add 40 to both sides. Add 40, add 40. There. And so the next line will be 9 times r plus 1 squared. The negative 40 and the plus 40 zeros out. And then the right side will now be just 36. There. Okay. Remember, we have a minus 4 there, a negative 4. We added 40. So that gives positive 36. This is 40 over here. There. That's a 40 plus 40. And you have a minus 4 there. So it's like 40 minus 4. And that's 36. Now, at this point, we shall divide both sides by the number 9. Okay, divide like that. And so this continues over here. Okay, the right side is now r plus 1 squared. And the right, that's the left side. Okay, the left side is r plus 1 squared. And then that's equal to 36 over 9. That's exactly 4 there. And so we take the square root of both sides. We have r plus 1 squared equals 4. We take the square root and square root. This becomes plus or minus square root of 4, which is plus or minus 2. Plus or minus 2. And the left side is just r plus 1. Okay. And the next line will be r. We are going to subtract 1 from both sides. We're going to subtract. So this will be minus 1 and minus 1. So this will continue like, let's continue in the other side. Okay. Let's continue in the other side. So from here, after subtracting 1 from both sides, this will have to continue in the other side. Let's go to the other side over here. All right, we have r plus 1. And then we have the plus or minus 2. Okay, we subtracted 1 from both sides. Minus 1 and minus 1. There. That means r is equal to plus or minus 2 minus 1. The first value, r1, will be the positive 2 minus 1. That is positive 1. And then the second value of r, let's call it r2, that's negative 2 minus 1. That adds up to negative 3. There. And so the answers are positive 1 and negative 3. There. All right, let us see the answer. Let us verify. Okay, it's up here. Let me just clear that part. Okay, you can see above my first line, that's 1, negative 3. It's over here. You can very well see it here. There, 1 and negative 3. Exactly our answers, 1 and negative 3. All right. So our answer is correct. I hope you were able to follow the step-by-step procedure. All right. So that will be for number 13. Our answers are correct. All right. Let's continue with 14. That's 14. Now here's 14. 5x squared plus 20x plus 10 equals negative 4. Solve by completing the square. Okay, let's start from the given. 5x squared plus 20x plus 10 equals negative 4. Okay, all right. Now you can notice the x squared is not coefficient 1. There's a 5. Okay, so we shall begin here. And we have the 5x squared and plus 20x. And there's a common factor, 5. We can factor out the 5. So factor out the 5. And this will now become x squared. If you take out 5 from 20, that leaves 4. There. Okay? So that takes care of the 20. You put out the 5, there's a 4. Okay? You can always verify by multiplying it back. Okay? So 5x squared and 20x. Now, we're going to put a space here because we're going to insert numbers there later. And then we continue by the plus 10 equals negative 4 there. All right. Now, what's the number to be added? We will start now with the familiar expression x squared plus 4x inside the parentheses. All right. Start with the 4. And then you divide by 2. That's the coefficient of the first degree. And then you square it. All right. Remember, it's always divide by 2, then square it. That's the way to get the number to be added to complete the square. So this turns out 2 squared. And finally, it's 2 squared. That's 2 times 2. That's 4. All right, so our number is 4. We add 4, we subtract 4 there. All right. Okay, perfectly legal. All right, that we added just 0. All right, so this is now the trinomial that we're going to convert, and this is presided by the 5 over there. Okay, so this is equivalent to x and 2. All right, I hope you still know how to do this. X and 2, the sign at the middle is plus, and this is squared there. Okay, I hope you have not forgotten that. All right. Okay, so we still have to be enclosing this part minus 4 there, like that. Okay, remember the minus 4 is there. Okay, that positive 4 and all the others became a binomial squared. All right. Then this will continue with the plus 10, and this is equal to negative 4 there. All right. Okay, so next thing to do is, all right, distribute the 5, okay? Distribute the 5 to the binomial, and removing some grouping symbol, this will become 5 times the quantity x plus 2 squared, okay? All right, and this will have to go back minus 20 and plus 10 equals negative 4. All right, what did we do there? The 5 is multiplied back and multiplied there. All right, okay. And so we remove now the parentheses, the square braces, and now we have to continue simplifying the numbers. So this will continue 5 times x plus 2 squared minus 20 and plus 10, that's a minus 10, and this is equal to negative 4 there. All right, to continue, we add 10 to both sides, add 10, add 10. And the right side becomes 6 there. Now the left side has the 5 and the x plus 2 squared. All right, no more number 10 there, okay, because that turns out negative 10 and plus 10, that's a 0. All right, we shall divide by the 5 here. Divide and divide by the 5. Cancels, and then you still have the 5 there. Okay, so this will continue over here. Okay, you have x plus 2 squared, and you have 6 over 5. So take the square root of both sides. This will become square root of 6 over 5 plus or minus. Okay, there. Now, we will have a denominator of square root of 5 here. Okay, square root of 5. Okay, remember, if you have a square root of 6 over 5, you can split this to square root of 6 over square root of 5, like that. So what we need to do is introduce a 5 inside. Okay, extending this like this. Okay, we can multiply this by 5 and multiply this by 5. And so the numerator will become square root of 30, and the denominator will give us square root of 25, which is reducible to 5. Okay, if you have a denominator with a square root, it's not simplified. If you can turn it to a whole number, that is simplified. Okay, so this is now square root of 30 over 5 there. Okay, so the equivalent of square root of 6 over 5 is right here. That's square root of 30 over 5. Okay, all right. So we're going to continue at the right side. This will turn out x plus 2 now. And this will be plus or minus square root of 30 over 5 there. Okay, after which we subtract 2. Okay, we're going to subtract 2 from both sides. So subtract 2 and subtract 2. There. And so this will now become x. X is equal to plus or minus square root of 30 over 5. And we have a minus 2 over there. Now, to make the denominator the same with a 5, okay, we shall introduce to the negative 2 a 5 over 5, okay, a 5 over 5. That's perfectly legal in math. 5 over 5 is just 1. So if you multiply the 2 with 5 over 5, like that, that will become negative 10 over 5, okay? Negative 10 over 5. Let's erase this part here at the left so we can add the continuation. All right, let me just remove that. Okay, we shall continue from there over here. Okay, you have there x that is equal to plus or minus square root of 30 over 5. And we have there negative 2 times 5 over 5. That will turn out minus 10 over 5. Minus 10 over 5. So making our denominator the same. Okay? And so we can rewrite this like plus square root of 30 over 5 minus 10 over 5. Okay? And so this is just the same denominator 5. Therefore, we can write this like square root of 30 minus 10 there over 5. That's our first answer. The other, this will be called x1, and then x2 will be called negative square root of 30, okay, minus 10, all right, minus 10 over 5. There. Okay, so we have two answers. Okay, this is the first and this is the second. There. So it's negative square root of 30 minus 10 over 5. All right, let's have the answers. Let us see. It's not visible at this point, so probably we can shrink it a little bit. Let us shrink it. All right, let me shrink it over there so we can have some space. Also, the answers will be shrinked. There. All right, we can see it clearly. All right, it did not erase our writings, but it shows the answer there. All right, so commutative property, okay, you can interchange the square root of 30, positive, and minus 10, okay, but it's just the same. All right, the first answer, which is over here, all right, that goes to this one, there. And then the second answer, which is there, it goes to the second one over there, right? Negative 10 plus square root of 30 is the same as square root of 30 minus 10. So this is also correct there. And also negative 10 minus square root of 30 is the same as negative square root of 30 minus 10. So they are the same, okay, over there. All right, so that completes our solution, okay? I hope you'll be able to follow step by step from the first line, okay? There. So I hope. All right. Let's continue with the next number. Let's do number 15. Let me erase the screen. All right. And let me erase the answer. Let's continue with the next line. Okay, here's number 15. All right. Maybe I should let that size be the right size so we will have more spaces. All right, let's start here. This is now number 15. Okay, I cannot make my writing any smaller. All right, so this will be 5r squared. Okay, Otherwise, it won't be visible anymore. You have 10r minus 33 equals 7. All right. Okay, we have here 5r squared, not just r squared. So we cannot start the completing the square procedure right away. So we will do factoring again. We'll begin here. It has to be r squared only, coefficient 1, okay? But this one is coefficient 5. All right, so we start by factoring the 5, okay? We're going to have r squared. When you factor out 5 from 10, you still have a 2. So this will be 2r there, okay? 5 times 2 is 10, 5 times 1 is 5. All right, so we're going to put some space here, and then followed by the minus 33, followed by the equals and the 7. All right, we start now with the inside parentheses. You can see now the coefficient of the first degree r, that's 2, okay? So we start with 2. You know what to do with this? You divide by 2, and then the result is squared. And 2 divided by 2 happens to be just 1. Squaring 1 is still 1, and that's our number. All right. So this number 1 is to be added and subtracted there. Okay. In that way, we added 0 only. All right. So we're now ready to transform this trinomial to a perfect square. All right. This will now be equivalent to r and 1, and the sign is plus. All right. Okay. We don't have to discuss that. We already discussed that from numbers 1 to 8. All right. So this is now, we'll continue with the minus 1 there. Okay. And the original parentheses will be there. Okay. And the number 5 is there, like that. Okay. After which we continue with the minus 33 equals 7. All right. Let's multiply back the 5. Okay. So this will be 5 times the binomial squared there. And the 5 goes with the negative 1 also. So that becomes minus 5. Then we can remove the parentheses, the larger one, the outer parentheses. And then this continues with minus 33 equals 7. Okay. Next, we have to combine the 5 and the 33. They are both negative, so this gives us negative 38. So this is negative 38 over here. And this is equals 7. And the remaining terms will still be there. 5 times r plus 1 squared. All right. We add 38 to both sides, okay, to isolate the binomial with r. So we add 38, making it 0, but we will add 38 here also. There. And so 38 plus 7, that's 45. So this gives us 45, positive. Now this zeroes out, okay? And so the left side will just be 5 times the quantity r plus 1 squared. Okay, next thing to do is divide by 5, okay? The number 45 be divided by 5, and also the left side like this. And so 5 divides by 5. And so this will continue like r plus 1 squared. And the right side is 45 over 5. Let's put a fence here. That's 45 divided by 5. That equates to 9. There. Okay, now we apply the square root to both sides. R plus 1 squared. This is 9. Take the square root there. Take the square root here. This is plus or minus. And so square root of 9 is 3. So we have a plus or minus 3. And the left side is r plus 1. Okay, let's continue over here. All right, we have r plus 1 equals plus or minus 3. There. So we subtract 1 from both sides. Minus 1 and minus 1. So the left side will just be r. First answer is positive 3 minus 1. It's a 2. That goes to our first answer. We'll call it R1. All right. Now we use the negative 3 minus 1. That results to negative 4. Okay. That gives us our R2. Okay. This is R2. Let me just clear that. Let me clear that. Okay. This is R2. That's a negative 4. All right. That's our second. All right. Let's check the answer. Okay, we have a positive 2, comma, negative 4. Those are the values over here. That means this and this are the roots of the equation. And so number 15 is solved. We shall continue with the next number. Let's have the next number 16. All right, here's number 16. Okay, we have 10x squared plus 20x minus 35, and this is equal to negative 3. All right. Now, you can see a coefficient of the x squared. It's not 1, it's a 10, okay? So we will factor out the 10. We'll concentrate on these first two terms, factor out the 10. And it's factorable. This will become 1x squared and plus 2x. The moment you put out the 10, the inside terms will have coefficient 1 for the x squared and coefficient 2 for the x. And then we provide a space because we will add something there later, followed by the minus 35 and equals negative 3 there. All right, we are now ready for the x squared plus 2x. We will now concentrate on the number 2. That number beside the x. We'll get that number, we'll divide by 2. The result is squared. So 2 divided by 2 is 1, and then squaring 1 is just 1, okay? This is our number. All right, our number 1 will be added and subtracted. So plus 1 minus 1 there. Okay, all right, you know what to do when you reach this part. These three terms here will be converted to a binomial squared, like that. Okay, the first term is just square root of x squared. Okay, the second term is the square root of 1. Square root of 1, well, just 1. All right, there. And then the sign here is, of course, the sign of the 2. Okay, it's a positive there. All right, and after which it follows, you still have the minus 1 there. Okay, all right, and this is supposed to be the original parentheses there. And the 10 is outside there, like that. And this is minus 35 equals negative 3 there. Okay, next thing to do is return the 10, okay? Return the 10 by multiplication. So you will multiply it here and multiply it there. So this will become 10 times x plus 1 squared. 10 times negative 1 is negative 10. Okay, the bigger parentheses or the outer is removed. And we continue with the minus 35 equals negative 3 there. So this will now continue with 10 times x plus 1 squared minus 45. Okay, minus 45 equals negative 3 there. And then we add 45. We add 45. And this will now be equal to 42. And this left side is just 10 times x plus 1 squared there. Okay, so after doing that, we shall divide by the 10, okay? So that we can solve for the x. All right, divide this by 10, divide this by 10, all right? The 10 cancels out with the 10. Next line is x plus 1 squared. And this is 42 over 10. 42 is divisible by 2. So we can reduce this to lowest term. And so is the number 10. So 42 divided by 2, that's 21. And 10 divided by 2, it's a 5. There. Okay. All right. And so we can continue over here. This will now be a square root. X plus 1 squared equals 21 over 5. All right. Take the square root of both sides. You get the square root of this and the square root of this. So this will be taken plus or minus. Okay. This will be plus or minus. The left side is x plus 1. And the right side is plus or minus square root of, what is square root of 21 over 5? Let's do it in a larger space here before we continue there. This is square root of 21 over 5. Okay, we can reduce the denominator such that it will not have a square root by making it square root of 25, because this is something like square root of 21 over square root of 5. You can split that to a square root divided by square root. So you can introduce here a square root of 5 over square root of 5, like that, making the denominator square root of 25. And then making the numerator, you can multiply the radicands. That gives us 105. There. 5 and 10. So that's equivalent to a square root of 105 over square root of 25, which is reduced now to an integer 5 there. And so the right side, going back to what we were doing, this will now be square root of 105 over 5 there. And then we will subtract 1. Okay, subtract 1. So subtract 1 and subtract 1, like that. Okay, we can continue back at the left side. We can now erase the left side. Okay, it's just the scratch writing here. Let's erase that. Okay, we shall continue with x plus 1 minus 1. So you can see it x plus 1, and this is equal to plus or minus square root of 105 over 5. There. If you subtract 1, you subtract 1. Okay? But 1 is equivalent to a number divided by a number. We can use the number 5. Okay? So the left side here is x. We can write the next line, the next expression like this, plus or minus square root of 105 over 5. And you can convert the 1 into something like 5 over 5. There. Okay? 5 over 5 is 1. Okay? All right. So we can make now the denominator the same. Okay? And we can write our x1. Okay. Our x1 can be written negative 5, okay, plus square root of 105. This will have a common denominator 5, like that. There. And then our x2, we can write our x2, all right, negative 5. Let me erase that. All right, negative 5 minus square root of 105 over 5. There. Okay, this will be our x1 and x2. Okay, this is our x1 over here. And this will be our x2. All right, let us verify the answers. There. Okay, so it's negative 5 plus the square root of 105 over 5. That's for the first one. The second root is negative 5 minus square root of 105. All right, exact. All right, that should be it. So these are the right answers. All right, so I hope you were able to follow the solution. Well, you have to do a little practice on square roots, okay, and how to simplify square roots, okay, with fractional radicands. All right, let's continue with 17. Let me clear the screen. After all, you can review or see the video later. You can rewind and see it for several times. All right, let's continue with 17. Let me clear the screen. Continue with 17. Here's number 17. 10n squared minus 20n minus 65 equals 3. Solve the equation by completing the square. All right, let's copy the problem first. 10n squared minus 20n minus 65 equals 3. All right. Again, our n squared here is not 1 coefficient. It's a 10. So we will have to do factoring out the 10. We will start here. In the first two terms, we factor out the 10. And then we have n squared. And factoring 10 from a 20, we still have negative 2n there. Okay, you can always verify 10n squared negative 20n there. Okay, then you put a space there followed by minus 65 equals 3 there. Okay, we are now ready to transform it to the solution. Okay, by completing the square, start with the 2. Start with the 2 divided by 2. And then the result is squared. We have 1 squared, and this is just 1. Okay, there. So our number is 1. Okay, so we're going to use this one to be added and subtracted. So add 1, subtract 1 there. And this will turn out reduced to a perfect square n with a 1. The sign at the middle is minus and then squared. Okay, followed by the minus 1. And we put the original parentheses, okay, and the number 10 outside, okay, and we have the minus 65 equals 3 there. Okay, next we will multiply back the 10, okay, so we're going to multiply back the 10. So the 10 goes with the binomial n minus 1 squared. It also be multiplied by the negative 1, so we're going to have a negative 10 there. After which we continue with the 65 negative equals 3. Okay, we shall add these two numbers here. They are both negative, so this will become negative 75. And this 10 times the binomial squared still here. There. And this equates to positive 3. All right, next thing to do is extinguish the 75 by way of addition. Add 75, making it 0. Add 75 also to the other side of the equation. That gives us the right side 78. So the right side is now 78. And the left side will now be no more 75s there. So this will just be 10 times n minus 1 squared there. Okay, we shall simplify the numbers. Okay, we shall divide by 10. Divide by 10, divide by 10. Okay, so 10 cancels out. We now have n minus 1 squared. Okay, the 78 over 10 is reducible to some lower fraction. Okay, 78 by 2, that will be about, how much is that? 39. 39. The 10, you divide by 2, it's a 5. So we divided by 2, the numerator and the denominator, making it 39 over 5. And 78 divided by 2, that's 39. 10 divided by 2, it's a 5. So we have a lower level fraction, 39 over 5. Okay, next thing to do is get the square root. All right, we shall continue over this space. We now have n minus 1 squared equals 39 over 5. Okay, we shall take the square root of both sides. Get the square root here and extract the square root there, making this plus or minus. Okay, and all right, the left side will be reduced to n minus 1. Okay, how about that square root of 39 over 5? Again, there will be a square root of 5 at the denominator. It will be reduced to a simpler version. That means without the square root of 5. Okay, what we mean by that is square root of 39 over 5. Okay, this means we have a square root of 39 at the numerator and square root of 5 at the denominator. All right, if you have a square root at the denominator, it is said to be not simplified. So we're going to make that an integer by introducing a square root of 5. So we will multiply the denominator by square root of 5. We will make that square root of 25. Okay, and when you do that, you also multiply the numerator. There, you call this rationalization. Okay, so square root of 5 over square root of 5 is just 1. So it's legal in math to do that. Square root of 5 over square root of 5 is 1. So you can multiply the expression by that. And so this will become square root of, how much is that? 45 and 4, 195. Okay, 5 times 9, 45, and 4, 15 plus 4, that's 19. So that will be square root of 195. The denominator is now square root of 25. There. Now we will be able to get a denominator integer here. Okay, so this is now equal to over 5. That's the square root of 25. The numerator remains square root of 195. There. So we're going back to what we were doing. This will now be n minus 1 at the right side of the screen plus or minus square root of 195 over 5. There. Okay. All right. Now next we add 2. Make that 1. Okay. We're going to extinguish the negative 1. Add 1. That becomes 0. We will just have n there. Okay. Now we're going to add 1 here also. There. Okay. And so the left side is just n. The negative 1 and the plus 1 cancels to 0. And the right side is now plus or minus square root of 195 over 5 plus 1. Okay. To make the denominator the same 5, we will transform the 1 like 5 over 5, just like in the previous problem. So this will look like plus or minus square root of 195 over 5 plus 5 over 5. There. That's the equivalent of 1, okay? 5 over 5. Now we have a common denominator, 5. And we are now ready to get our n1 and n2. We shall erase the square roots here at the left side, okay? All right, we already finished doing that, okay? All right, you can do that at the paper, all right. Next, we will do now the continuation, all right? Just move to the left side of the screen. This will now be n. Okay, that's plus or minus square root of 195 over 5 plus 5 over 5. Let's write it this way. 5 over 5, all right, plus or minus square root of 195 over 5. All right, there. Same thing, okay? Commutative property. And so we can write our N1. N1 is 5 plus square root of 195 over 5. That's our first answer. N2, we shall write this 5 minus square root of 195 over 5. All right. These are our answers. Okay. So first and the second. All right. Now let us see the answers. Let me reduce the screen. Okay. Let me reduce the screen. No, reduce the numbers. I mean the size of the letter so we can see the answers so that it will fit. Okay. All right. Let us see it there. All right. Okay, so that is 5 plus square root of 195 over 5, and 5 minus square root of 195 over 5. All right, it's correct. The computer will not show the solution, okay? What we're doing here, all right? So it's this part that you need to learn, okay? The computer will display only the answers, okay? So you need to learn how to do this part here, the steps. All right, so let's continue with the next number. Let's continue with the next number. We shall clear number 17. All right, let's continue with the next. I think this is the last number. All right, let's finish it. This is now solved by completing the square. You have 4a squared minus 8a. 4a squared minus 8a minus 32 equals 6. All right. I can see all even numbers, okay? Even numbers. And we can make the numbers smaller, okay? We can make the numbers smaller. They are all divisible by 2, okay? Before we start anything else, we shall divide each by 2, both sides, okay? Like that. We cannot divide by 4, okay? Because the 6 is not divisible by 4. Now, using the 2, we'll divide them with 0 remainder. All right. Next line, 4 over 2, this will become 2a squared. And then 8 over 2, that will become negative 4a. And the 32 divided by 2, that's a 16 negative. And the right side is 3 there. All right. At least we were able to make the numbers smaller. Okay. Okay. But still, our coefficient for the a squared is not 1, okay? It's a 2. So we will be dealing with the first two terms. Get the factors out. We shall factor out the 2. And we will encounter a squared minus 2a there, okay? All right, our factoring is correct. 2a squared, negative 4a, yes. Now we provide a space for the add and subtract, and then followed by the 16 negative equals 3 there. All right, now we'll start the completing the square procedure. Okay, we start with the negative 2, so we will take that 2 and then we will divide by 2, and then the result is squared. So 2 over 2 is 1 squared, and that will just be 1. Okay, this is our number. Okay, that's the number to be added and subtracted. So plus 1 minus 1. Okay, now take note of the trinomial. This is now a perfect square trinomial. Okay, it has 3 terms. That's why it's trinomial. All right, perfect square trinomial is equivalent to the binomial squared. This is a, this is 1. The sign will be a minus there. And we still have the negative 1 over here. All right, this will now be enclosed by the original parentheses. Okay, and the 2 is out there. This is followed by minus 16 equals 3. All right. Okay. Now we multiply back the 2. Multiply the 2 there. Multiply the 2 with the -1. So the next line is 2 times the quantity a minus 1 squared. The 2 and the -1 is -2. Okay. Now you can remove the outer parentheses. This will be followed by the -16 equals 3. All right, there. After which, next line is combine these two here. That's -18 equals 3. And you still have the 2 times the quantity a minus 1 squared. There. Okay, next line, add 18 to isolate the binomial. So add 18 here, add 18 here at the right side. All right. This becomes 0. The -18 and the +18, that becomes 0. We will only have on the left side 2 times a minus 1 squared. And so this equates to 18 plus 3, 21. There. Okay, next line is divide by the 2. So you have 2a minus 1 squared equals 21. Divide by 2, both sides. All right, the 2 cancels out. We will now have just a minus 1 squared equals 21 over 2. We cannot reduce the 21 over 2. All right, so we will take the square root of both sides. Square root. All right, this will now have square root here and square root there, plus or minus. And the next line is a minus 1 equal to plus or minus square root of 21 over 2. Plus or minus. Okay, let me clear that. This is now square root of 21 over 2. There. Okay, plus or minus. Okay, we shall continue at the left side. This will now be a minus 1. That's equal to plus or minus square root of 21 over 2. Okay, now we shall simplify that square root of 21 over 2 by introducing square root of 2 over square root of 2. Okay, just like what we did a while ago. All right, let me just do that separately. Okay, square root of 21 over 2. We can do a multiplication here by square root of 2 over square root of 2, which will make this square root of 42 over square root of 4. Okay, like that. And so this continues with square root of 42 over 2. There. That's the equivalent of square root of 21 over 2. Okay, we cannot have a square root of 2 at the denominator. Okay, that will not be simplified. So this must be square root of 42 over 2. That's the equivalent of square root of 21 over 2. Okay, so we can continue with the square root of 42 over 2, replacing the square root of 21 over 2. Okay, so let's clear the square roots so we can continue writing. We know the simplification already. Okay, this will now be plus 1 to both sides. Okay, plus 1 to both sides. So this will now be plus 1 here and plus 1 here. There. And so this will continue a equals plus or minus. We will now replace it. Okay, replace that with square root of 42 over 2. Square root of 42 over 2. And the denominator is rationalized. Okay, so we have square root of 42 over 2 plus 2 over 2. Because we can convert this one, we can convert that to 2 over 2, making it with the same denominator. There. Okay, so we can have just divided by 2, okay, over 2, like that. And so we can now simplify our answers. Let me erase this part so that we can write our answers. This will now be written A1. Okay, we can make this with the same denominator too, like this. And then we can write the 2 first, then plus square root of 42. There. And that's our first answer. And then our A2, we can write the 2 followed by the minus square root of 42 all over 2. This is our second root there. And these are our answers, okay? And we can now verify the answers. All right, let us see. This is our answer. All right, let us shrink it further so that it will be fitted. Okay, here are the answers. Okay, can we make it larger a little bit? Okay, you can see it there. 2 plus the square root of 42 over 2, comma, and then 2 minus the square root of 42 over 2. These are exactly our answers. All right, so these are correct. I hope all the needed steps are written and you'll be able to follow it from the beginning. Okay, this is our last number. I hope you were able to learn from the steps. This is the topic under completing the square and used to solve quadratic equations. Thanks for learning and see you later and goodbye.